Hello everyone, I am Punyakeerthi and welcome to LangChain tutorial from Python to GenAI. In this series, we will learn LangChain step by step and build real-world AI applications together. So let's get started. Today's topic is Introduction to LangChain. Let's start with introduction. See, large language models, we call them as LLMs, such as OpenAI GPT, Gemini, Claude, Mistral, and Llama have changed the way software applications are built. Instead of writing complicated business logic for every possible user question, developers can now ask an AI model to understand instructions and generate intelligent responses. Although every LLM provider offers its own API, building applications directly with these APIs becomes difficult as projects grow. This is where LangChain becomes valuable. LangChain provides a common framework that makes it easier to build AI-powered applications without worrying about the differences between multiple AI providers. So, before LangChain, what happens? Let's see. When ChatGPT became popular, developers quickly realized that its capabilities could be used in many kinds of applications. Examples like AI chatbots, email assistants, customer support systems, document search, knowledge base assistants, internal company tools, research assistants, content generation. The challenge was that developers had to communicate directly with the APIs provided by the companies such as OpenAI, Google, Anthropic, and others. Every provider had different API endpoints, different request formats, different response structures, different authentication methods. This made development more complicated. Let's understand example without LangChain. Suppose you want to generate a text using OpenAI. Let's go to code and we'll see the output. See, I have used OpenAI SDK for calling a text-based output. So from OpenAI import, I have imported the key here in the code and we are calling OpenAI class and passing the API key. Then we are calling client.chat completions to create using model and we are sending a messages. This is the format which is used to call LLM model GPT 4.1 with role as user and with the content explain artificial intelligence. For this, we will get a response. From that response, we have to extract a content like this. This is one way of accessing the content from the response given by the GPT model. So, OpenAI gave the response like this. Okay, we got the response right. So, now you think I have used this OpenAI generate text using OpenAI, but later if we decide to use Gemini instead of OpenAI, you must learn an entirely different SDK and read it your application. That Gemini API look like this. See, the client we are calling GenAI.client, the imports are different. Also, while you are calling client.model generate content, that is also different, and the model which you are passing is different. Here you are able to see response.text. We are getting the response.text. This is different, and in OpenAI, the response dot choices we have to get. So that is different, and it gives response like this. So we have to learn new SDKs on the basis of the models are provider. If you are using different providers, if you use, we need to learn different SDKs. So let's learn what is LangChain. As per the definition, LangChain is an open source framework. It is designed to help developers to build applications powered by large language models. Instead of working directly with every provider's API, LangChain offers a consistent interface that works with many different models. Think of LangChain as a bridge between your application and multiple AI models. Let's understand simple analogy. Imagine every television brand has different remote control. Without LangChain, Samsung Remote A, Sony Remote B, LG Remote C. You must learn different remote for each TV. LangChain acts like a universal remote controller. One interface works for many different AI models on the basis of different AI providers. So let's understand why was LangChain created. As AI adoption increased, developers encountered several problems. First problem is every provider has a different API. As we already say, See, OpenAI has different API, Gemini has different API. Each AI company designed its own API. For example, OpenAI, Gemini, Claude, Mistral all require different code. Learning each API takes time. Problem 2. Applications become hard to maintain. Imagine building an application with Gemini. 6 months later, another model performs better. Switching providers often requires changing large portions of your code. Problem 3. AI APIs keep changing. LLM providers frequently introduce new parameters, new features, new authentication methods, new models as well. Without an abstraction layer, developers must constantly update their applications. Let's go with problem 4. Production applications need more than text generation. Real AI systems usually include prompt templates, document retrieval, vector databases, memory, tool calling, output parsing, streaming, caching. Managing all of these individually becomes difficult. LangChain provides reusable building blocks for these common tasks. Main features of LangChain. Unified interface. The biggest advantage of LangChain is its consistent programming interface. Instead of learning different SDKs, developers use the same workflow across the multiple providers. Let's understand with the example. I want to use a OpenAI. So for that, we have to import LangChain OpenAI import chat OpenAI. It is a just a chat OpenAI class which will have parameters like model and API key. Once I have passed the API key, LLM is ready, then we can invoke LLM invoke with our prompt, then we will get the response.content. Here you see these two lines and these are different. Let's, if you want to shift using LangChain to an Gemini, then no need to change too much. See, we are importing LangChain Google GenAI import chat, then the class has been changed, but calling LLM.invoke, so what is machine learning, that is same. Response.content, that is also same. Both in both the cases in Gemini and OpenAI using LangChain, most of the code is same. Notice that only the model class changes, the rest of the application logic remains almost identical. Let's understand with the explanation. The method invoke works consistently across different support models. This means developers do not need to rewrite their application whenever they switch providers. Let's understand second part, prompt templates. Writing prompts repeatedly leads to duplicated code. LangChain allows developers to define reusable templates. From LangChain core prompts, import prompt template. Prompt is equal to prompt template dot from template. So here we have a topic called simple language. So formatted text work like this. Let's take this code and core prompts, if we install and we can run, we are able to see that. Oh, and when you print, we are able to get the prompt. So in this way, we will get the explain neural networks. We can pass the topic, whichever topic using formatted, then we can call the prompt invoke. Automatically it will works. So why we need to use the prompt templates? Benefits include reusable prompts, cleaner code, easier maintenance, dynamic variables, reduced repetition. Let's talk about structured output. Applications often need machine readable responses instead of plain text. So instead of we get like this, John is 28 years old, we need them in JSON format like the name is John, age is 28. Here we have only 2 attributes variance. So in the real world, there will be like more than 10 to 12 attributes or more than 50 attributes we need for the database access and all. At that moment, this structure output will be necessary. This structured format is easier to store in databases, send to APIs, display in user interfaces, validate automatically. LangChain helps simplify structured output handling even when provider support varies. Next one is tool calling. AI models sometimes need external information. For example, weather, database queries, calculations, APIs, search engines. LangChain provides a standard approach for integrating tools with LLMs. Then Retrieval-Augmented Generation. Many applications need answer based on private documents rather than the model's built-in knowledge. For example, company policies, legal documents, medical records, technical manuals. LangChain simplifies integration with vector databases and document retrieval systems, making RAG applications easier to build. Next is memory. Memory allows an AI application to remember previous parts of conversation. Without memory, when user asks, "My name is Raval, Later, if I ask question like what is my name, so AI will respond, I don't know. But with memory, AI can respond, your name is Rahul. This creates more natural conversational experience. So why not use provider APIs directly? This is one of the basic question when we are learning the LangChain we get. So direct APIs work well for simple or experimental projects. However, as applications become more complex, several challenges arise. Each provider has unique APIs. SDKs evolve over time. Switching providers requires significant code changes. Advanced workflows must often be built from scratch. LangChain addresses these issues by providing a common development model across providers. So let's understand with some simple example scenario. Imagine you are building an AI assistant. Initially you use Gemini. Later you discover that Claude performs better for coding tasks. Without LangChain, learn the new SDK, rewrite API calls, update requesting and response handling, test everything again. But with LangChain, before the LLM call will be like chat Google Generative AI, only this class we have to change. But after that, you just change LLM is equal to chat Anthropic. Most of the surrounding application code remains unchanged. So let's go with what are the real world applications with LangChain. LangChain is commonly used for AI chatbots, customer support assistants, document question and answer systems, PDF summarization, knowledge based search, code generation tools, email drafting, research assistants, AI agents, workflow automation. Let's best practices. Keep prompts modular using templates. Design applications so models can be swapped easily. Separate business logic from LLM specific code. Return structured outputs whenever possible. Use memory only when it adds value. Test with multiple models to find the best fit for each task. So, key takeaways from this lesson. LangChain is a framework for building applications powered by large language models. It offers a unified interface for multiple AI providers. It simplifies prompt management, structured output, memory, tool integration, and RAG. It reduces the effort required to switch between different AI models. It helps developers build scalable, maintainable AI applications more efficiently. Let's recap of this lesson. In this lesson, you learned what LangChain is, why it was created, and how it simplifies AI application development. You explored the challenges of working directly with the different LLM APIs and saw how LangChain provides a consistent interface across providers. You also learned about key features such as prompt templates, structured output, tool calling, memory, and RAG, along with practical code examples that show how LangChain can reduce development effort and improve maintainability. So thank you for watching. If you found this video helpful, please like, subscribe and turn on notifications so you don't miss the next lesson. I will see you in the next video. Happy learning. Thank you.